Hi guys, it's Stan from MRC Design Lab. So today we're going to do a bit of a deep dive on the early stages of the design process. Chris and I worked together to create the front clamshell of the MRC, basically from the windscreen forwards. I had quite a few comments on the 3D scanning video asking if they can buy the scanned files. There's a rear section, a mid section, and a front section. If you would like this for your own project, I'll put a link down in the description and hopefully it helps some of you out. So about a year before we even bought the MRS to scan, we came up with an initial concept. We were aiming for the front to be based off the 962C Porsche, the side to be based off of the 787B Mazda, the rear to be from a C9 Sauber. So we merged these three ideas together with the MRS wheelbase. Now that we have the 3D scan of the car, which you guys will have seen in our recent video, we can bring that scan into our CAD software. By doing this, we can see what is going to work and what isn't going to work from our initial concept and our 3D scan. The 3D scan poking through the body will show what needs to be cut away or changed in the actual model. So as you can see, there's a few areas that needs to change, but overall it's looking okay. Blender is a fantastic animation software that has 3D modeling and rendering capabilities. Its workflow doesn't really tie in with the mechanical engineering based tools that I'm used to. This is due to the fact that Blender uses mesh modeling, whereas all of the other softwares that I've used in the past are solid based. It has a very free-flowing and creator-friendly way of modeling, but it's not very dimension focused. This makes it fantastic for concepts and quick modeling. In SolidWorks, everything starts with a sketch. That means that everything's derived from dimensions and mathematical formulas. This is great for mechanical engineering, but not great for organic shapes. It does have fantastic tools such as adding threads to holes and aligning multiple components together. I stumbled across plasticity a few years ago as a similar workflow to a lot of the 3D modeling softwares I'd used in the past. It seems to be fairly free-flowing. It still has some dimensioning capabilities, but it also feels like a nice best of both worlds scenario between something like Blender and SolidWorks. Unfortunately, it's not parametric, but the fact that I can use it to generate the nice smooth surfaces and then import it back into SolidWorks and edit it directly is a huge bonus. This means that when I want to include more components down the road, I can do it in a SolidWorks assembly. To begin with, we'll rough out a few solids, which will be the front, the side, the rear, and the roof. Now, as I mentioned before, the front's going to be from the Porsche, the side's going to be from the Mazda, and then the rear is going to be the Sauber. What I haven't mentioned yet was the roof. Now, as we're going from the standard MRS windscreen, which obviously this isn't the MRS, but it's quite square compared to the teardrop shape of the actual Group C cars, we have to do some pretty clever design work to go from quite a square shape to a really nice smooth round. We looked for a lot of inspiration for existing cars that do this. One day at a hot rod show, I saw a C6 Corvette, which in New Zealand is very uncommon, there's not many here. That seemed to have a really nice shape to it. So I managed to find a model online of the roof of the C6 Corvette, cut it up a little bit, stretch the proportions slightly to suit, and as you can see here, this is good enough for now. Now that we've got these rough proportions in place, we can go and refine certain areas. To start with, we chose the nose or the front clamshell because this is the most detail and it's probably the hardest area to do. So we thought if we start with this, once we get it done, the rest should be easy. Looking at this, we can see that the wheel wells and the front lower section seems to be good. The issue that we're coming into is how high the firewall is below the front windscreen, and we need to find a nice transition to merge all of that together. We tried quite a few different ideas, but we ended up with something that's quite similar to what Nissan used in the R90 CK. You can see it's got 2 vents either side of the bulge in the middle of the bonnet. We need that bulge to house some of the components in the front of the car, like power steering pumps and all those sorts of things. We now have these 2 areas either side of that bulge inside of the fenders that is basically a wall. So we thought we'd cut out a hole there and then duct that behind the front wheel and out at the bottom of the fender. Now I would love to use Air Shaper or something like that to do some CFD analysis. Unfortunately at this stage it's out of the budget. If you know of any alternatives that are affordable, let me know down in the comments and I'll take a look. So we tried to think practically, using simple sketches to rough out our ideas, making sure that any air coming in has an exit path. So now that we've decided what shape we're going to go with, we need to do some detailed design work and refine this hood bulge. Using surfacing, I've created 2 different variations side by side. Turning on the zebra stripes allows me to see how the surfaces interact and which side I think looks best. After doing this a few times, I refined it to a point that I was somewhat happy with it, and then I deleted it all. I ended up recreating the center section from scratch, using some of the shapes I developed earlier as a guide. After a couple of attempts, I ended up at something that I was happy with. Now, one of the issues that I came across when modeling, I go into way too much depth and detail. A lot of this is quite unnecessary because it's going to be 3D printed, a mold's going to be made of it, it's going to be refined by hand, so the fact that I'm going into all this detail with G2 continuity is probably a bit excessive. It was an experience for me. My background's mainly in solid modeling, so surface modeling is kind of like that next level up of complexity, which I love. So a lot of this is kind of overkill, but it'll make Chris's life easier when he comes to do the bodywork, so I thought I may as well give it a go. So I want to join these 2 panels together. This is the top of the front fender and the center section that sits on top of the firewall. I found the best way was to create these tangential lines on the bodywork and then project down onto it. You get 2 nice lines that give you the surface shape and direction. Use the bridge feature, it gives you a nice transition between the 2 surfaces. If you use lofting, this will create a new surface that bridges the gap. I did this a few times, then in any tricky areas I used X-NURBS, which patches between each of the loft features. This seemed to give the nicest kind of continuity when I turned on the zebra stripes. We're both pretty happy with this front design. The bulge may change very slightly. It's got exactly what we want in that it's got front fenders of the Porsche 962C. It's got that nice bonnet dip with the fenders either side. And then it's got a solution for the chassis that we're using, which we've styled kind of like the Nissan. So next we'll be working on the sides and the roof, and then we can work on the rear. Thanks for watching, and I'll catch you in the next video.